Welcome to the lecture on control of DC motors. You can see that DC motors, these are small motors and are inexpensive and suitable for the hobbyist purpose. These motors are used in robot bases, as you can see in this picture, used in quadcopters, and also in model planes and boats. Okay. Now DC motor operations, the basic operations, as you know, that motor shaft is the armature. Here you can see this is the armature, which is the motor shaft. Armature has coils of wires. Here you can see armature coils. These are the armature coils. Coils connected to commutator. Here you can see these coils are connected to the commutator. This one is the commutator. Then connections are called the brushes. So here you can see these two are the brushes through which the power is supplied. Now outside of motor has permanent magnets. Here you can see these two, N and S. These two are permanent magnets. This is basically the stator. And DC current applied to commutator. DC current applied to the commutator. Magnetic field is formed in the coils. Coil magnet interact with the permanent magnet. As armature rotates, polarity is reversed, and this is a brushed motor. Okay. Now the DC motor speed, how it can be controlled. The speed of the DC motor can be controlled by the voltage supply. Here you can see, we already know that in the pulse width modulation we can do with the help of Arduino. And here you can see, if we use a 25% duty cycle, then the average voltage that is going 3 volt, okay, instead of total 12 volt maybe. For 100% duty cycle, if it is 12 volt, for 25% it is only 3 volt average. If you increase the duty cycle to 50%, you will get, you see, around 6 volt, and at 90% you can see 10.8 volt. So that means in the pulse width modulation pin, if we can change the duty cycle, then it is possible to change the voltages supplied to the DC motor, hence the speed can be controlled. Okay. Now the rotational direction of the DC motor also can be controlled, and for that this H bridge is required. Now the name is H bridge because here you can see that 1, 2, 3, 4 switches are there, and here you can see it is forming as if forming a H, and here you can see one motor is there in the bridge. Okay, that is why the H bridge name comes from. You see the H, why the name H bridge. And what is actually done here, you can see that if these two switches are open and these two switches are closed, then current will flow through the motor in this direction. Then suppose the motor is moving in the clockwise direction, and if these two switches are open and these two switches are closed, then current will flow in the opposite direction and motor will rotate in the counterclockwise direction. Okay, so in this way, by controlling these switches, it is possible to change the direction of motors. Okay, and these switches are not the mechanical switches, these are transistors or MOSFET, those are used. So this one is a motor driver, L298N DC motor driver, and this particular module is helpful in maintaining the H bridge connection. Okay, so it's a dual H bridge. That means dual because the two motors can be connected with this one. The speed also can be controlled, direction can be controlled because it is H bridge is there, and DC motor voltage in the order of 5 to 35 volt, and the peak current is 2 ampere. This is what is the specification of L298N DC motor driver. So just see what are the different pins of L298N. This is a very commonly used DC motor driver. Here you can see there are 3 pins. One is the motor power, that is supply power. another one is a common ground, another one is 5 volt optional. Okay, here you can see two switches here, two pins here. These two, through these two pins you can connect one motor, and here you can see another two pins through which you can connect other motor. So two motors can be connected in these two pins. Now you see there are 6 pins here. These are very important. You see the first 3 pins, motor A enable, then motor A input 1, then motor A input 2, and next 3 pins are for the motor B, the second motor, for which one is enable pin and one input 3, another one input 4. Okay, so these are the different pins which are there. You see the physical structure of L290-8N can be different, but basically the pins are same. Okay, these are the different pins like power pins, ground and all that, and here you can see how the motors are connected like this. Okay, now motor A, how it is controlled with these pins. So motor A, you have seen that there is one enable pin, right? For each motor there is one enable pin. You see, for each motor there is one enable pin. What is that? Here you can see all these pin positions. So enable A. So for motor A, maybe this is the enable pin. So one enable pin and two input pin. Input 1, input 2. Similarly for the motor B, one enable pin and two input pin. Input 3 and input 4. Okay. Actually these are the pins by which it is connected to the Arduino. So this enable A, that means motor A enable pin, if in the enable pin, if you give 5 volt, then it will be enabled. That means the motor will run at a full speed if you give 5 volt. If you connect this enable pin with the ground, then motor A will not rotate at all. And if you give a voltage at enable pin between 0 and 5, then its speed will be some intermediate value. That means in the enable pin you have to connect with the PWM pin to control the speed. Okay, and if you give 5 volt, then it will be at a high speed. If it is connected to ground, then motor A will not rotate. And in between, through PWM, we can give some in between voltage. In that case, the speed will be intermediate. Now motor A input 1 and input 2. In input 1, if you give 5 volt, and input 2 if you give ground, then it will rotate in one direction. Okay, suppose in the clockwise direction. So input 1 5 volt, input 2 ground. And if you just connect it reverse, that means if you give signal that input 1 is ground and input 2 is 5, then it will rotate in the reverse direction. That's all. So how you can change the direction, you can see. Okay, so input 1 5 volt, input 2 ground, then clockwise, and input 1 ground and input 2 5 volt, then it will reverse. Okay, these are simple digital pins you have to connect, need not to connect with the PWM pins, but only the enable pins has to be connected with the PWM. Okay, then for the motor B, exactly the similar way this will work. Now how it is connected, you see here the motors are connected. Here it is the power pins. You can see a 7.4 volt supply. Suppose this is a 6 volt motor. For 6 volt motor, since the switches that you have seen in the form of transistors, they actually certain voltage drop is there around 0.7 volt. So for the two switches it will be 1.4 volt. So that is 7.4 volt is shown here to accommodate 6 volt. So anyway, so power supplied, this is the common ground which is connected here, and here you can see the 5 volt supply is also given. Another 5 volt supply is there, that 5 volt supply is given here. Okay, and the common ground, other one is the common ground, and you can see this 5 volt supply and the ground supply is given to these two lines, and here all the pins like enable input 1 input 2, enable 2 input 1 input 3 input 4. So these are taken here. Now if you give 5 volt to enable 1, then definitely motor A will run. In which direction, that depends on input 1 and input 2, which one is 5 volt and which one is ground. Okay, similarly for the motor B. So you can see if enable 1 is active, that means if it is enable 1 is given 5 volt and input 1 is given 5 volt and input 2 is ground, then motor A will rotate in the forward direction. Okay, and here you can see enable 2 is grounded, that means motor B is disabled, so motor B is off for this particular connection. Okay, similarly for the Arduino, you can connect the pins in this way, that enable 1, suppose pin number 9, input 1 8, input 2 7, input 3 5, input 4 4, and enable 2 3. See, important thing that enable 2 and enable 1 must be connected to the PWM pins. Okay, and the remaining things are exactly same. Here you can see it is possible to control these two motors with the help of potentiometers. You know how to connect potentiometers. So depending upon the rotation in the knob of the potentiometer, it is possible to control the speed of each of the motors. And in this way, basically, we can use it in a robot car, maybe. Okay, in the wheels, these motors are connected, and in the joysticks, you know, joysticks are basically potentiometers. So this potentiometer, rotation of this potentiometer, by this rotation we can control the speed of each wheels, okay, through which these motors are connected. Now we have seen L298N motor driver. Now let us see another H-bridge motor driver. This is L293D. This also can be used, and you know that how to identify a pin. Here is the notch, so counting will start from here. So 1 2 3 4 8, then 9 10 11 12 up to 16. So 16 pin IC L293D. This is also the same thing like 298N, only the configurations are a bit different. You see, again the two motors can be connected, and motors are connected between output 1 pin and output 2 pins, one motor, and output 3 and output 4, another motor, right? And enable 1, you can see this is the enable 1 pin, and input 1 pin, input 2 pins, you can see. Similarly, you see enable 2 pin and input 3, input 4 pins. So these pins already you have seen there. Extra thing here you can see 2 ground and 2 ground. These have to be connected with the ground definitely. And regarding power source, here you can see 9 volt to 12 volt battery power source can be given, and here you can see the 5 volt power supply can be given. Okay, so this is what is the circuit, the pin configurations of L293D. I am discussing L293 because in Tinkercad you will get this L293D, but you do not get L298N. Okay, so let us make a circuit that will control the speed of two DC motors. Suppose motor speed of motor B will be controlled by a potentiometer, and motor A can be on or off by a single push button. Okay, that means if you press the push button, motor will start and it will remain, it will run till you do not press it again. Okay, so if you press it again, then it will off. Again, if you press it, then it will start rotating. Okay, so in this way you have to design it. Okay, let us try to do this problem. So go to the Tinkercad platform. Last day we have done this one, where one potentiometer and one the push button is already there. Let us duplicate this one. Let us first change the name, demo DC motor control. Okay. So first thing that we want to change is, let us remove these LEDs. Okay. Okay, so we have removed LED and we can see that this push button is connected to pin number 2 and this potentiometer is connected to A0. Okay, now we want to control to DC motors, so let us take to DC motors. So here is the DC motor. So take 1, 2. So we take 2 DC motor. One will be controlled by this potentiometer, and this one will be controlled by this potentiometer. This one will be controlled by the push button. Okay. What else you need? You need the motor driver. So L293D. So here is the H bridge motor driver. So place it here. Okay. Now what else we require? We require extra power supply. So for that, what we do, uh, let us take one power supply, take one IC that will give the 5V power supply voltage regulator. Okay, so take one 5V voltage regulator IC 7805. Let's check what is there. Okay, 7805 5V voltage regulator is there, so that we'll use to supply our power. Okay, so here is one input, ground and output. Okay, so 5V input is to be more than, if you give some more than 5V, it will at the output will give only 5V. Okay, so let us give some voltage. Suppose we have 9V battery and let's rotate it. From that 9V battery, let us give power to the input and to the ground, and here output, let us give that output directly to this pin. Okay, and ground, common ground to this pin. So remember, this is a voltage regulator IC, that means at the output it will give the 5V. So here basically you will get 1 5V, here 0. Now what we do, we'll connect this two motors with the IC. So let us see how to connect. Remember that between output 1 and output 2 you have to connect the motor. Okay, say this is motor A and this one is motor B, right? So you can also check the connection. You see, between output 1 and output 2 motor is to be connected. Similarly, between output 3 and output 4 another motor is to be connected. Okay, so first connect motor A and motor B between outputs. So here is output 1, you can see. So from output 1 you just connect this one, and this one is output 2. So from output 2 we just connect other one. So we have connected between output 1 and output 2 with the motor A. Now connect motor B between output 3 and output 4. Okay, so here it is output 3. So output 3 and output 4. Output 3, output 4. So we have connected these two motors with the driver. Now we have to connect all the pins like enable 1, then input 1, input 2, enable 2, input 3, input 4 with the Arduino board. Okay, so first you connect where is enable. This is enable 1 and 2. That means for input 1 and 2 this is the enable pin. That means for the motor A this is the enable pin. So this enable pin you connect with one PWM pin. So we have to connect it to pin number 11. Okay, connected to pin number 11. And where is another enable pin? Here is the enable pin for motor B that will control input 3 and input 4, right? So this enable pin you connect, this enable pin you connect to another PWM pin. So that PWM pin is pin 10. Okay, so this is enable 3, 4. That pin we have connected with pin number 10. So two enable pins for two motors we have connected. Then input 1, input 2 for motor A, input 1 and input 2 is to be connected, and this can be any digital pins. Okay, so input 1 you connect to say pin number 13, and input 2, input 1, input 2 you connect to say pin number 12. So you connect it to pin number 12. So we have connected input 1 and input 2, the pin number 13 and 12. Now input 3 and input 4 that we have to connect. So you connect input 3, this is input 3, input 3, connect to any pin, say you connect it to pin number 7. Okay, and you connect input 4. Where is input 4? Input 4, you connect input 4 to so we have connected input 4 to pin number 4. Okay, so we have connected for the motor array 3 pins in a enable pin and input 1 input 2 for motor B enable pin and input 3 input 4 that we have connected. Now we have to connect the power pins. Let us see the power pins that we have to connect. You can see that one will be the 5V, another we are using 5V battery, so 5V. So these two power pins we have to connect to the 5V. Okay, so here is the power pin, so we connect to the 5V battery. So we have connected this end with the 5 volt of the battery supply, because battery supply is coming here through the voltage regulator, and this one we connect with the Arduino 5 volt. So we have connected this end. This is power 1 and this is power 2. So we have connected Arduino. So in this way we have completed our connection. Only thing that is remaining, this ground. So we have to ground these pins. These are ground pins that we have to ground. So what do you do? Just join these two, because both of them are ground. Similarly join these two. Both of them are ground. Okay. Now you just this ground it, in similar way you ground it. So in this way we have completed our connection. Okay, the thing that you have to remember, that what are the pins through which this enable pins and input pins are connected with the Arduino. Now let us write the code. First you remove what was there earlier. Let us write the code in the Arduino sketch and then we will copy it here. So what is our problem? Our problem is we want to control motor A on or off by a push button switch, right? And control speed of motor B by a potentiometer. So initially what we have to do, we have to define the different pins. So first there are two input pins by push button and potentiometer. So define int push pin equal to, push pin is connected to pin number 2. Okay, so that is 2, and potentiometer pin, that is pot pin, that is connected to pin number A0. Okay, now let us define what are the other pins, like the 6 pins that we have connected for integer motor A enable 1, right? Enable 1, motor A enable 1, this pin, or you can simply write, okay, let us write it, motor A enable 1 pin. This particular pin is what? Motor A enable 1, that is a PWM pin, and we have connected it to pin number 11. Okay, here you can see the pin number 11, we have connected enable 1, so pin number 11. Then what are the input pins for motor 1? The input pins are the green ones, so one is 13 and another one is 12. 13 and 12. So int motor A input 1. Okay, motor A input 1 is equal to 13 and input 2, that is 12. Okay, so in this way we have defined the pins of motor A. Now similarly for the motor B, it will be say motor B enable, basically enable what? Enable 2. Okay, or you can write here basically to enable motor A. Okay, so enable 1 2 we have written here, and here basically to enable 3 and 4. Okay, so motor B en 3 4, that is what? That enable pin is pin number 10. Pin number 10 is that one. So 10. So here you can see in the diagram, this is what is enable 3, and you see enable 3 goes here, here, then here. In this way it goes to pin number 10. So here now motor B input 3 and input 4. Motor B input 3 and input 4. Now input 3 and input 4, these two actually what? These purple color pins, right? So which one is 3? 3 is this one, that is 7, and another one is 7 and 4. Okay, 3 and 4 are 7 and 4. Pin number 7 and pin number 4. Okay, so these are the pins. This is for the motor A and these are motor B. Now after defining these pins, we just specify those in the void setup. So within void setup, pin mode this push pin is what? Definitely input, right? Similarly this one pot pin, this is also input. So these two are from the push button and potentiometer. Then coming to the motor A pins, okay. Motor A pins are these pins are all output pins. Okay, we are giving output through this pin. These are output pins, enable pin, then input pins. also output pin. Then this one is input 2. This is also output pin. Now similarly for motor B, enable 3-4 and motor B input 3 and motor B input 4. Okay, so we have defined all the pins. So all the pins we have defined. Next, what we do, we want write the program in the main loop section. Okay. So we have to take reading from the push button, and based on that we have to make certain action. So now the handling push button is bit tricky, because previously in LED brightness, LED on off, we have seen that if you press the push button then it is maybe on, and if you release it then it will off. But now you just press a single time and it will operate. So you have to write it properly. See, you first make a conditional statement that if this is what is the statement, how if is written. This is a while loop open, this is while loop end, this is setup. What is this? Okay. Now you see that if digital read push pin, because digital read push pin will give either 1 or 0 depending upon whether you press it or not, right? So digital read push pin if digital read push pin is equal to 1, that means if you have pushed it then it will become 1, and for the conditional statement equal to is written twice. And let us define a integer button state. Okay, and button state, suppose there is a variable called button state, and if the button state is 0, then it will take certain action. What action? It will count the number of pressing. Okay, so let us define another variable called pressed is equal to 0, then pressed equal to pressed plus 1. So in this way the pressed, we make a counter and we'll check if it is pressed, then pressed will become pressed plus 1. Initially it was 0. Now if one time pressed, then it will become 1. And you change this button state. From button state initially it was 0. So change the button state. If you press, then change the button state from 0 to 1. So just flip it. Okay. So button state equal to 1. Okay. Now if this is not true, that means if you do not press it, then what will happen? If you do not press it, then else if you see else if statement is not showing, it should show different color. Probably a gap will be there. Yes, a gap will be there. So else if what that condition is, again just copy it and paste it. Now if it is 0, that means if you do not press it, and if you find that button state is 1 instead of 0, if button state is 1, then what action you want to take? You just make the button state again 0. That's all. But you do not increase the counter of pressed, because now it was not pressed, but we just make it button state equal to 0. So if this condition is done, then automatically within the pressed variable, the number of times you are pressing, that will be noted. Okay, so if the number of times you have pressed it odd, that means it is in a pressed condition, that it should on. And if it is even, that means it should be in a off condition. Okay, so we just want to use this thing. So then what we do, accordingly we have to run motor A. So if we find that this pressed variable is odd or even, how can we identify whether it is odd or even? So we divide by 2, and if we get non-zero remainder, then it will be odd, right? So %2 is the modulus variable that will return the remainder if you divide it by this one. So here it is 2. So if you divide it by 2, then what is the remainder? If this remainder is not equal to 1, if this remainder is not equal to 0, the remainder is not equal to 0, that means it is odd. That means motor has to run, right? So what is the condition? The motor, how can you run? It is very simple. You just write enable 1, you have to activate, right? So you just want to run, you do not want to control the speed, so you just run at a full speed. Okay, so for that you can just simply digital write. So you can simply use digital write. If you want to control the speed, then PWM question is coming, and in that case you can do accordingly. So now we are simply using the motor A, enable pin number is this one. So what we do, this we make high, that's all, and it will it should rotate in which direction? So for the clockwise direction we have to give a digital write this one, Control C, this one high, right? And the other one, that means the input 2, that means the input 2, you just make it low. Then what will happen? It means motor will run at a full speed and it will move in a forward direction. And if it is not true, then what will happen? If it is not true, then else if to see, that means if you do not press it, then it will be 0, and at that time what will be your action? Action will be simply enable 1 will be off. That means enable 1 will be low. That's all. So if you do that, then motor control with the help of push button is over. What is next? The next is you have to control motor B. So for that, first you have to take the data from the potentiometer. So how can we take that data from the potentiometer? Some sensor value that you have to read, say int pot sensor, right? Pot sensor is equal to what? That is equal to analog read which pin? Pot pin. Okay, so within the pot sensor we just take the value of the pot pin within the pot sensor variable. Now what we do, we just map it. This value is from 0 to 1023. We have to convert it into PWM pin, so from 0 to 255. So simply touch a speed sensor, and this is new variable, so write float. So what we do, we define a new variable, that is speed sensor, and that will be a float variable, speed sensor. Okay, so that float variable will be what? So that you have to map between 0 to 1023 to that. So that will map this pot sensor value, right, to what? 0, 23 to 0, 255. So in this way we get the speed sensor value. So now the speed sensor value once with you, then using that you can just simply control the motor B. So I will control the motor B, that you just enable, like in this case instead of a digital write you have to write analog write, right? So analog write motor B, So what is motor B pin? This is enable pin. And that you have to give the brightness value, that means the sensor value, and that sensor value is the speed sensor. Okay, so enable 1 will get. Now about the direction will be simply like this. Suppose in the forward direction, for motor B, input 3 and motor B input 4. Okay, so in this way it is possible to control the speed of the motor B using the potentiometer sensor. Okay, I think I have not made any mistake. Let's check it. Control C, copy it and paste it in the Tinkercad domain. Okay, now let's run it and see whether there is any error or not. Okay, error is there. In function void loop, one value required as left operand of assignment, one value required as left operand 43 and 47. Digital read, push pin, digital read push pin is equal to 1. Okay, we have made one mistake here. This is a conditional statement, so always the equal to will be followed by another equal to symbol. Okay, so that was a mistake. Let's check how it's working or not. Okay, now it is working. Now let's check first whether our push button is working or not. This is our motor A. Press it and we have released it, and you see this is what is the speed at which it is rotating. Now if you press it again, you see it becomes 0. Now go to this one, you see already it is rotating, and if you move the wiper, you see the speed is gradually decreasing, and here it will become 0. And as you move this potentiometer, gradually the speed is increasing. You can see the speed is gradually increasing as you move the wiper. Okay, so things are working. Okay, I hope you got the idea that how to connect and how to write the program. Okay, thank you.